Today we were going to discuss about the Islamic mathematical knowledge and computational procedures. Good day everyone,
I am John Lawrence S. Pandak.
and I am Sarah Jean B. Pase. The Islamic Golden Age was a period of remarkable advancement in algebra, trigonometry, and computational methods, shaping both Islamic and European mathematics.
House of Wisdom. So the House of Wisdom in Islamic language, it is known as Bait al-Hikmah, also called as the Grand Library in Baghdad. No, it also acted as one of the world's largest library during the Islamic Golden Age and was established in the early 9th century by Caliph al-Rashid. So just like what I said, House of Wisdom is one of the largest library during the Islamic Golden Age, and many Islamic mathematician goes there to have their studies, to create their own work, to create their own masterpiece, in which, in result, there is the creation of algebra, geometry, the development of trigonometry, even in medicine.
Al-Khwarizmi played a crucial role in establishing algebra as a distinct discipline, introducing Arabic numerals and the concept of zero, and pioneering algorithms which later influenced modern computation. Next is Al-Karaji, born on around 953 to 1029 Common Era. Further advanced algebra by extending arithmetic operations to algebraic terms, allowing unknowns to be treated as numbers and simplifying complex equations. In addition to these contributions, Islamic scholars made significant advancement in trigonometry. Figures like Al-Batani, Abu al-Wafa, and Al-Biruni synthesized Greek and Indian approaches, introducing new functions and tables that greatly enhance astronomical calculations and geographical mapping. Before we explore to our topics, these are the aims of our topic. First, to explore the historical development of mathematical knowledge during the Islamic Golden Age. Second, to recognize the significant contributions of key figures like Al-Khwarizmi and their impact on mathematics today. Third, is to understand the computational procedures introduced by Islamic mathematicians. Now class, who is Al-Khwarizmi in Islamic mathematics? Al-Khwarizmi born around 780 CE in Khwarizm, or it also known for in today's generation modern-day Uzbekistan or Turkmenistan. Al-Khwarizmi worked at the House of Wisdom in Bahad under Caliph al-Mamun. He is also a polymath who contributed to mathematics, astronomy, geography, and more. So who was Al-Khwarizmi? Well, he's a giant in the history of Islamic mathematics. And get this, he's often called the father of algebra. Think about for a second. All those X and Y's you've wrestled with, we owe a lot of that to this guy. Not only did he lay the foundations for algebra, but he also developed the concept of algorithm. Yes, that algorithm. Think computer science, think step-by-step problem solving. That's Al-Khwarizmi's influence echoing through the centuries. He also wrote a hugely important book called Kitab al-Jabar wa al-Mukabala. We'll dig into that title a bit later. And he played a vital role in popularizing Hindu-Arabic numerals. Basically, mo na siya ang numbers nga atong ginagamit everyday. Ang 0 until 9 nga number. Mo na siya ang Hindu-Arabic numerals. His full name was Muhammad ibn Musa al-Khwarizmi. The word algorithm is actually derived from a Latinized version of his name, algorithmi. His name literally became a fundamental concept in computer science and beyond. And that book I mentioned the Kitab al-Jabr wa al-Mukabala. It translates to the compenditious book on calculation by completion and balancing. It was written around 820 CE. And as you know, the term algebra itself comes from algebra, the part of the book's title. So, Al-Khwarizmi didn't just do algebra, he gave it its name. Let's break down the title even further. Algebra means restoring or completion. In mathematical terms, it refers to the process of adding the same quantity to both sides of an equation to simplify things. The next one is al-mukabala, means balancing, and that involves subtracting the same positive quantity from both sides to simplify things even more. The book is all about these techniques. Ultimately, Kitab al-Jabr wa al-Mukabala aimed to introduce systematic ways to solve linear and quadratic equation. Now, unsa day point gyud sa algebra? Well, the slide tells us the core idea. Algebra is a way to solve problems with unknown numbers. The purpose of algebra is to provide a systematic way to solve problems involving unknown values and relationships between numbers. It is used to first solve equations, second analyze patterns and relationships, third model real-life situations, fourth generalize arithmetic, and the fifth is to develop logical thinking. Okay, now, let's put algebra into practice with a real-life example. This problem is about a father leaving an inheritance to his three children. A father left his 500,000 pesos inheritance to his three children, Anna, Ben, and Carl. Anna received twice as much as Ben, and Carl received 50,000 pesos more than Ben. How much did each children receive? Ang unang step is to put everything in numbers. This makes everything easy. So we can define the variable Ben, Anna, and Carl. Ben is our first X. The second is Anna, who got 2 times than Ben. So, it represents as 2x. And the final sum gets x plus 50,000. Remember that these letters will represent our variables. Now we put everything together to solve for Ben. The first x. We combine them and say that the sum of everything must be equal to 500,000. The rest of the solving process is addition and subtraction. Now, human naman ta mag-define sa step 1 sa variables, mag-proceed tayo sa step 2. Ang share ni Ben. Una na to, ang share ni Ben og pangita kay para didto ata mag-base sa share ni Anna og kang Carl. Now that we are done na maghanap sa ilang mga variables, ato ana nang i-combine tanan. So now, i-combine na nato tanan. X plus 2x plus x plus 50,000 equals to 500,000. Karon, ato ana i-combine like terms. So 2x plus 2x plus 50,000 equals to 500,000. Now, ato na po na siyang i-add. So, 2x plus 2x equals 4x. So, copy ang 50,000 equals to 500,000. And then, sa next steps, kay tanggalon si 50,000 deraa. Katapad ni 4x. Ibalhin si 50,000 dito akang 500,000. So, ana iyahang formation. So, 4x plus 50,000, i-minus na to 50,000 para mawala siya. And then, ibalhin na to si 50,000 dito akang 500,000. Now, i-crash out na to na sila kay result na siya og 0. So, ang nahibilin kay si 4x equals to 500,000 minus 50,000 equals to 450,000. Karon, para mabilin si x, ato nang i-divide sa 4. Both sides. So, crash out, x, ang mabilin, and then, aming result kay 112,500. So, muna siya ang first x. Muna ang share ni Ben. So, now, kabalo naman ta sa value ni x, which is katong bahin ni Ben. Ang next na punto pangitan na kay kang ana nga share. So, 2 Then, i-copy lang nimo tong value ni x. So, i-calculate nato para makabalo sa result. Then, ang ming result kay 225,000 pesos. So, mao daw na ang bahin ni Ana. Therefore, Ana's share is 225,000 pesos. Next is kay Carl. So, i-copy lang nato ang value ni X, which is katong kang Ben nga share, and then, i-add nato sa 50,000. And, i-calculate na po nato para sure jud. So, aming result kay 162,500 pesos. Mauna ang bahin ni Carl. Therefore, muna na siya tanan. As I add up those three shares, may result siya og 500,000 pesos. Algorithmi also develop algorithm. So what is algorithm? Algorithm is a set of step-by-step instructions that describe how to perform a task. So in short, algorithm kay man siyang step-by-step procedures. Like for instance, unsay rule di ay sa pag-add? Di ba mag-una man ka na sa right side? Mo na siyang first step of adding a numbers, right? In short, algorithm is a step-by-step instructions. Algorithmic contribution on Hindu-Arabic numeral system. Now, what is Hindu-Arabic numeral system? Hindu-Arabic numeral system, which we use every day. The digits 0 to 9 was originally developed by Indian mathematicians between the 1st and 4th centuries CE. This system introduced two major innovations. The first one is the positional notation. The value of a digit depends on its position in the number. For example, in 123, the 1 represents hundreds, meaning to say that isa lang daw ang 100 sa 123. And then next is the 2 represents as tens. So pasabot, duhad kabuok tens ang naa sa 23. And then next is 3 is mo na siyang ones, meaning to say nga nada tulo ka buok ones ang naa sa 23. The second one is 0 as a placeholder. And Indian mathematicians introduced the concept of zero, which was revolutionary. It allowed for the representation of large numbers and simplified calculations. Zero acts as a placeholder, allowing us to distinguish between numbers like 1 and 10 or 10 and 100. Think about the number 1024. The zero in the hundreds place indicates that there are no hundreds. Without a placeholder like zero, it would be impossible to accurately represent this number and distinguish it. Now the question is, how did Al-Khwarizmi connect to this Indo-Arabic numeral system if the Indian mathematicians developed it? And what did he do with Hindu-Arabic numerals? Al-Khwarizmi wrote a book called On the Calculation with Hindu Numerals around 825 CE. In this book, he explained how to use the Hindu-Arabic numeral systems for arithmetic operations like addition, subtraction, multiplication, and division. His work introduced this numeral system to the Islamic world and later Europe when it was translated into Latin. If you're going to ask me why Al-Khwarizmi is connected to Hindu-Arabic numeral system, it is because Al-Khwarizmi, although he was not the inventor of the Hindu-Arabic numeral system, but he was a key figure in its spread and adaptation across the Middle East and Europe. His work not only popularized the use of these numerals, but also laid the foundation for modern algebra. Today, we use these numerals and algebraic methods in countless ways, from simple arithmetic to complex scientific calculation.
Let's talk about one of the pioneer of Islamic mathematics, Al-Qaraji. His full name is Abu Bakr ibn Muhammad ibn al-Husayn al-Qaraji. So he was a Persian mathematician who lived during the late 10th century. He lived in Baghdad for most of his life, and that he wrote his mathematical works during the time when he lived in that city. He was also influenced by Al-Khwarizmi. So, Al-Karaji is also known as the first person who free algebra from geometrical operations and replace them with the type of operation that we use today, which is the arithmetic operation. Now, we'll proceed to the contribution of Al-Karaji in Islamic mathematics. So, his first contribution is that he wrote books in mathematics. Specifically, he wrote three books. Number one is Al-Badi fil Hisab. So, it means wonderful on calculation. So, this book literally deals with calculation, including the topics like binomial theorem, expansion, and Pascal triangle. And the second book is Al-Fari fil Jabar wal Muqabala. So this means glorious on algebra. This work focuses on algebra. From the word, from the meaning itself, glorious on algebra. So it focuses on algebra like solving equation, arithmetization of algebra. No. And the third one is al-kafi filisab, which means sufficient on calculation. So this book, offering a comprehensive treatment on arithmetic calculation. Let's proceed to the second contribution of Al-Karaji in the field of mathematics. The second contribution is arithmetization of algebra. Al-Karaji's most significant contribution was extending arithmetic operations to algebraic terms. This innovation allowed mathematicians to treat unknown as if they were numbers, using arithmetic instruments to solve equations. His work, Al-Fari, is considered as one of the milestones in the development of algebra. Karaji make a significant contribution into the field of algebra. No? Just like what I said earlier, that he was the first person who free algebra in terms of geometry calculation. And one of his major contribution into the field of algebra is this what we call arithmetic, no? Arithmetization of algebra. No? He developed this arithmetization of algebra, which a very big deal because it means that mathematicians could handle problems more easily by treating unknowns like x or y, no? As if they were the regular number. In his book, Al-Fari, which means glorious on algebra, he explained these ideas. His work is seen and was considered as one of the major step in the history of algebra, specifically in his work of arithmetization. We're going to talk about the next contribution of Al-Karaji, which is the binomial theorem. So, one of the biggest contribution of Al-Karaji is binomial theorem. By discovering the law of formation of coefficients and constructing a table similar to Pascal's triangle to facilitate the expansion of binomials raised to powers. Archaeology provided a systematic method of expanding expression of the form a plus b to the power of n. Archaeology binomial theorem was based on Pascal triangle, where he presented a table. This one, guys. This is the table Al-Karaji presented. By using this table, for example, guys, like a plus b to the power of 4. So we're going to find the number 4, which is, its coefficient is 1, 4, 6, 4, and 1. By using this table, we can easily determine the coefficient of the terms. And this binomial theorem of Al-Karaji had a significant impact on the development of algebra and in mathematics in general. And still today, we are using this work or masterpiece of Al-Karaji, which is the binomial theorem. Now we'll proceed to the impacts and influence of Al-Karaji in the modern mathematics. Al-Karaji's work influenced the mathematicians such as Ibn al-Haytham and Ibn Yunus, who further developed algebraic methods. His contribution laid the groundwork for the algebraic techniques used in the modern mathematics. So his work was studied by the later mathematicians in both Islamic world and Europe. His work served as a bridge in developing the later mathematics. And the second one is that by applying arithmetic operations to the algebraic expression, Al-Karaji expanded the scope of algebraic methods. This approach enabled the simplification of a complex equation and facilitated the development of more advanced algebraic techniques. So he contributed to the foundational principles of the algebra, no, this arithmetic and in general in mathematics. So his work enabled the late mathematicians to easily uh, easily apply this arithmetic in the algebra. This is the computational procedure of Al-Karaji in arithmetization. He showed it in the book of Al-Fari, which means the glories of on algebra. So find the values of x that satisfy the equation of x squared plus 10x equals 39. So the first step that we're going to do is to rearrange the rearrange it into the standard form. So the x squared plus 10x minus 39 equals 0. And after that, we're going to get the half of the coefficient of x, now which will give us 5, and we're going to square it. So square it, and it will give us 25. After that, we're going to distribute 25 to both sides. It will look like this: x squared plus 10x plus 25 equals 39 plus 25. That we're going to simplify. No? And it will look like this: since x squared plus 10x plus 25 is a perfect square, so it will look like x plus 5 to the power up to, and equals 39 plus 25, it will give us 64. Step, we're going to square it both sides, so it will give us the square of x plus 5 to the power of 2 is x plus 5 equals the square of 64, which will give us 8. That we're going to subtract both sides by 5 to get the exact result. So it will look like this. We're going to subtract it by 5, and also 8, subtract it by 5. Then we're going to cancel that one. It will give us x equals 3. So that is the result. X equals 3. This is a quadratic equation, so it will have two solutions. So the next thing that we're going to do is to write like x plus 5 equals negative 8. We will also both subtract by 5. So cancel this one. It will give us x equals negative 13. This is the result. negative 13. To know if the answer is to know if the both answer is correct, we're going to verify it. So the thing that we're going to do is to replace the x by the result, which is 3 and 13. So since it is x squared plus 10x equals 39, so we're going to replace this x equals 3. So replace x with 3. So 3 squared plus 10. And then we're going to replace the x with 3, no, which will give us, no, 3 squared will give us 9. And then 10 times 3 will give us 30, which will result to 39. So it is correct. So the same process, we're going to replace x with negative 13. So negative 13 squared plus 10 times negative 13. Negative 13 squared is 169. Result of 10 times negative 13 will give us negative 130. So 169 plus negative 130 will give us 39. So it is also correct. Therefore, the value of x that will satisfy the equation of x squared plus 10x equals 39 is x equals 3 and x equals negative 13. That's all. Thank you. So now let's proceed to the mathematicians who contributed in the field of trigonometry. So the first one is Al-Batani. So Al-Batani's full name is Abu Abdullah Muhammad ibn Jabir ibn Sinan al-Raqi al-Hirani al-Sabi al-Batani. So he was born on 858 AD in Haran, Turkey, and he died in 929 AD at the age of 71 in Samarra, Iraq. So the contribution of Al-Batani is that he introduced a new trigonometric function. So his most notable contribution was his work on trigonometry. He was the first to replace the use of Greek chords with the sin, which is a fundamental concept in trigonometry. The second one is he created tables for cotangents. So he used Al-Mirawi's idea of tangents, which means shadows, to develop the equation for calculating tangents and cotangents and compiling them in the tables. No, and the third one is develop formulas in spherical trigonometry. So he made some significant contribution to spherical trigonometry, including the formula for the sun side and the table of sin and tangent. And the fourth one is the advanced astronomical calculation and instrument. Let's proceed to the importance of Al-Batani in trigonometry. So Al-Batani significance in the modern trigonometry lies in his pioneering use of the sine and tangent functions, replacing the Greek method of chords, and his development of more accurate methods for calculating trigonometric function. So he laid the um, the groundwork for the future advancement in the field of trigonometry. All his work make a significant contribution in the development of mathematics, and also his work in trigonometry serve as the major foundation in the modern mathematics. No? Now let's proceed to Abu al-Wafa. His full name is Abu al-Wafa Muhammad ibn Yahya ibn Ismail ibn al-Abbas al-Buzani. He was born on June 10, 940, in Buzan, Iran, and died on July 998 in Baghdad, Iraq. He was a Persian mathematician and astronomer who worked in Baghdad. He made important innovations in spherical trigonometry, and his contribution are the following. He introduced the tangent, secant, and cosecant to the Arab mathematics. So he developed a method for uh, computing tables. As an astronomer, he worked in Baghdad Observatory, where he created the first wall quadrant, a device used in observing the movement of heavenly bodies. And the next one is that he applied spherical trigonometry to astronomy. So Al Abu Al Wafa, he made a significant contribution to the spherical trigonometry and applied it to the astronomy, including the developing new methods for calculating trigonometric function and compiling tables for them. And the next one is that he contributed to the development of trigonometric tables. So he developed trigonometric tables, including devising methods for calculating them with the improved and accuracy. And also he compiled the tables of sines and tangents. And he also devised a new method for calculating sin tables, achieving an accuracy of 8 decimal places, surpassing Ptolemy's table. In conclusion, Muhammad ibn Musa al-Khwarizmi, the father of algebra, made significant contribution to mathematics and beyond. His work laid the foundation for algebra as an independent discipline and introduced algorithms which are fundamental to modern computing. As Al-Khwarizmi also popularized the Hindu-Arabic numeral system, simplifying arithmetic and paving the way for advancement in various fields, including computer science, engineering, and finance. Furthermore, Al-Karaji extended arithmetic operations to algebraic terms, influencing later mathematicians and laying the groundwork for algebraic techniques used in modern mathematics, from inheritance laws and trade calculations to the Renaissance and modern mathematical and computational systems. Al-Khwarizmi's influence, alongside that of figures like Al-Karaji, solidifies, solidifies their legacy as pivotal figures in the history of mathematics. Also, Al-Batani and Abu al-Wafa's contribution to trigonometry is very important in bridging ancient Greek knowledge with the advancement of later mathematicians. Al-Battani significantly improved the accuracy of trigonometric tables, refined the calculation of sin, tangents, while Abu al-Wafa further developed in spherical trigonometry, introducing new trigonomic functions like tangent and cotangent, and providing more precise trigonometric tables. His systematic approach to solving trigonometric problems and his geometric demonstrations make an advancement to the field of mathematics. That's all. Thank you, class, for listening to our report.